Hello, everyone, and welcome to Summer with the Science Center and our first ever virtual star party with the Royal Astronomical Society of Canada, Toronto Centre. My name is Rachel. I'm a researcher programmer at the Ontario Science Centre in Astronomy and Space Sciences, and we have a really fun evening planned for all of you. Our star parties are something that we typically do every summer with the RASC, where out front of our building we'll have telescopes, talks, and some really fun activities. So while we can't be all together right now, we can join you virtually and bring you a little bit of a flavor of what those star parties are like in your own home. So I have a few things I want to touch on before we begin. I want to acknowledge that I'm obviously not presenting from the Ontario Science Centre. I'm presenting to you from my own home, which is in Toronto, which is the territory of the Haudenosaunee, the Wendat peoples, and the Anishinaabe, including the Mississaugas of the Credit, and is now home to many First Nations, Inuit, and Métis peoples. Toronto is also covered by Treaty 13 with the Mississaugas of the Credit. And as a settler, I'm grateful to be able to live and work on this land alongside the Indigenous peoples with whom we peaceably share this land and who have cared for it since time immemorial. Some of you may be watching from all over Ontario, all over Canada. We're always encouraged to find out more about the peoples, treaties, and the land that we live on. There's many resources available. One that I found helpful was the website whos.land, and there's also another really useful website, native-land.ca. I want to mention that this virtual star party will be interactive, so we'll be looking at you to write some messages back to us in the chat. We'll want to engage a little bit in a dialogue with all of you, and we're looking forward to engaging with you throughout this event. We welcome your comments and your questions in the YouTube chat. And while, of course, we're open to respectful dialogue and discussion, any users posting any racist, misogynistic, or otherwise offensive and inappropriate comments will be blocked to ensure a safe, inclusive, and enjoyable experience for fellow viewers, our staff, and our partners. Now, mentioning our staff and partners, I would love to introduce my co-hosts for this evening. We have Rochelle, host from the Ontario Science Centre. Hi, Rochelle. Good to see you.
Hi, Rachel.
And we have Chris from the RASC. Great to see you, Chris. Behind the scenes, at their telescopes, we have Claudio, Francois, and Blake. And behind the scenes, we have a whole team bringing this to you, Ward, Andrew, Jana, and Angel. So shout out to all of them, and thanks for making this happen. We're so excited to get started and share with you this amazing event. So the first thing that I want to pose to all of you is a question, is how many of you have ever looked through a telescope? That's something that I'm really curious about. We're going to be seeing some telescope views later tonight. We're also going to be doing some space trivia, so get your trivia hats on, grab your science notebooks. We're going to be talking about meteors and comets, taking your questions about planets and deep space objects and stars. So we're open to all things here for the next 2 hours. So first up, I would love to do some trivia. Wouldn't you, Rochelle?
I would.
Awesome.
Because what's a party without trivia games and all that? So our space trivia tonight will be your opportunity to interact. You can put your answers in the chat. Unfortunately, we are not offering prizes tonight, except for the best one, bragging rights. And even if you just for participating, you will actually be a star tonight. So our first question, let's start off easy. What is the largest planet in our solar system? Feel free to pop your answers in the chat. This is a pretty easy one. We want to start fairly simple. This planet in our solar system is so big you could fit all the other planets in our solar system within it. Have you guessed?
Some things to think about. We're talking largest by size, not mass, right, Rochelle?
Yes, that's correct.
Well, also by mass, probably.
By mass. Yeah.
We're seeing some comments coming in. Jupiter, Pluto. Want to give them the answer, Rochelle?
Yeah.
All right.
Last minute, okay, and the answer, of course, is Jupiter.
That's the most popular in our chat. Like you said, that was a pretty easy one to start with.
Yeah.
But it's okay if you didn't know.
That's all right. It's so big, you could put 1,300 planet Earths within Jupiter. That's
a lot.
Huge.
And the Earth is huge.
Yeah, it's true. Now, let's try a different question, a little bit harder this time. Can you name a planet that has rings?
That's a good question. What are the rings made of? Are they solid, Rochelle? Something to think about.
Yeah, I kind of am afraid to give away any hints at this point because I'm going to guess that our audience tonight is going to have some idea. Rachel, what are we seeing in terms of the answers?
We're seeing a lot of people thinking maybe the gas giants. Lots of Saturn.
Yeah, lots of Saturns, exactly. But did you know all the gas giants actually have rings? So that means Jupiter, Saturn, Neptune, Uranus and Neptune all have rings too.
Yeah, we saw some Uranuses and looks like some Jupiter is responding as well.
Yeah.
So well done.
It's pretty cool. Like, I mean, Saturn's rings, of course, are so big. And I know that a lot of you know that it's actually, a lot of the rings aren't solid. They are made of trillions of particles of dust and rocks and ice all orbiting around the gas giants. But did you know that Saturn's rings could actually be seen by the astronomer Galileo over 400 years ago by using a telescope? You know, we had to discover some of the other rings around the other planets with the help of advanced technologies like sending out probes and astronomical telescopes there before we can see it. So it's kind of a neat thing, and hopefully we get a chance to see Saturn tonight, so you'll stick around to see that. Now, well, let's do one more question because we're talking about planetary features, and this one's one of my favorites. Can you name the planet that has the Great Red Spot?
That is a good one. That is a good question.
Yeah. So Great Red Spot.
There's also a planet that has a Great Dark Spot. Maybe bonus points if people guess that one too.
Yeah. Do it. You can put your answers in the YouTube chat. I have a feeling a lot of people know this. It's been I almost gave it away. Maybe we could give the answer then.
Yeah. That's okay. We're seeing, a lot of Jupiter as well.
Yeah, Jupiter has been in the news a lot the last few years, of course, right? It's been in the news a lot because we've had several missions to study Jupiter. The most recent one, of course, being Juno. And just a question, does anybody out there know what the Great Red Spot of Jupiter actually is?
Oh, that's a good question.
Yeah.
So Jupiter has this Great Red Spot, a gas giant planet. So that means that planet is mostly made up of gas, maybe an icy core at the center. So lots and lots of clouds, lots of layers of clouds. So that's a bit of a hint as to what that object, that red spot on Jupiter might be. What does it maybe remind you of or look like? Something similar to what you might have seen on Earth. So something to think about. If you don't have your science notebooks with you, I encourage you to grab them, and maybe you can keep a tally of the trivia throughout the night. As Rochelle said, you can give yourself points. You can play along with your family and your friends. You can score, and like Rochelle said too, bragging rights.
Yeah, that's right. You know, I'm kind of sensing a theme here, Rachel, in terms of the trivia questions.
Yeah, we've been talking a lot about Jupiter, haven't we? We're seeing in the chat someone also mentioned that Jupiter's Great Red Spot is probably a storm. So yeah, you're right. It is a huge storm on Jupiter. So all things Jupiter, we're talking gas giants. We touched a little bit on Saturn. So that is the theme of the beginning of this evening. We're talking planets. And I think, I love looking at Jupiter. Jupiter is like an amazing planet because of those multicolored bands and that great red spot. Saturn is also a stunning planet with its rings. I like Neptune as well because of that beautiful blue color. What's your favorite planet, Rochelle?
Oh my gosh. I'm going to have to go with what's most familiar to me, and of course that would be Earth. I didn't have a star shirt tonight, so I wore my planet shirt. But a close second would likely be Mars. I mean, just think it's the one that we might potentially be able to travel to next as human beings. And it was so much like our planet Earth when it was first evolving billions of years ago.
That's a really
So
good
it's
point.
kind of exciting too. And we are actually sending out Perseverance there to help us learn a little bit more about that.
Yeah, it's busy. The trip, the route to Mars is packed with missions right now. The United Arab Emirates also sent the Hope mission back in July as well. And I believe China also sent a mission also. So it's a lot of really exciting things on the horizon for Mars. We would love to know from all of you, what is your favorite planet? We're going to do a poll right now. So write in the chat, let us know what's your favorite planet. We'll tally it up and we'll tell you the first, second, and third place winner later tonight as we see what your rankings are for your favorite planets. Rochelle shared some good thoughts on what her favorites were. What about you, Chris? Do you have a favorite planet?
I have different categories. So my favorite planet to show somebody with a telescope would be Saturn. But my favorite one to look at myself, I think, is probably Neptune or Mars. And I was looking at Mars last night.
Awesome. Awesome. It is beautiful to see. And last year, no, 2 years ago now, oh my goodness. Time doesn't mean anything anymore. 2 years ago, Mars was at its brightest since quite a long time. And later this year, we're going to see it at opposition again. Isn't that right?
Yep. Closest to the Earth, I think around October 9th, and then at opposition around the 12th. So for about a week, we'll have peak Mars. And
Something to think about.
Maybe preview that a bit later with Stellarium.
Yeah. Awesome.
Rachel?
Yes?
A question came in from Paper and Pencil. Rocks and debris, what rings are made of?
Wanting to know what the rings are made of. So the rings are, as Rochelle said, they're not solid. They're made up of many small particles. So Saturn's rings in particular have a lot of ice. And that's why we can see those ones so well, because all the sunlight reflects off of that ice back into our eyes and makes for its rings to be stunningly bright. The rings around Jupiter, Uranus, and Neptune are a lot more dusty. So they tend to be picked up in the infrared, different wavelengths of light that our eyes are not as sensitive to, but special telescopes are able to actually see them and detect them. So lots of very tiny particles, and the Cassini around around Saturn quite a few years ago actually took a dive through the rings of Saturn. So it's very fine dust, definitely not solid. Thanks for pointing out that question, Rochelle.
Yeah. And if anybody else out there has some questions for us here tonight, feel free to add them in the chat. Don't forget to keep putting your favorite planet and why, because, I can't promise anything, but I have a feeling we'll get to see some, at least one planet tonight.
I think we're gonna hopefully see a planet now. Let's see. Let's take a look at those telescope views and take a look and see if we can spot Jupiter. It looks like it may be clouding out in our skies, but we have some views we can share with you. Okay, this is absolutely incredible. So this is sort of what Jupiter would look like if you were looking at it through a telescope. So this is a recording of Jupiter that you can see. So that is amazing. You can see those bands, and now you can see the processed image, all those different images that were taken by the camera on the telescope stacked together to bring out those details. And you can see those bands of Jupiter similar to what we saw in those photos earlier. And you might even be able to spot right near the top, just towards the tip of the edge of that band, almost a tiny black spot. And so Jupiter has many moons. I can't even keep track of how many moons. Rochelle or Chris, do you know how many moons Jupiter's at right now? I think it's 63.
I wanted to say 63, but I know they're making discoveries all the time.
Yeah.
I think it's 79 for Jupiter, I think.
Oh my
I'm looking at
goodness.
the NASA data page.
They've updated it since I last cracked open a textbook.
Oh
So you
yes,
can
you've got to keep
see.
checking back.
That's why they invented the internet. So what's amazing is that Jupiter's 4 largest moons can actually be spotted through a telescope and through most binoculars. Isn't that right?
Yeah.
Yeah, exactly. In fact, last night, not only can you see the moons, but occasionally when the moons pass between the planet and the sun, they can cast little brown black shadows onto the planet's surface. And even a backyard telescope can see those dark round spots as they pass across the face of Jupiter. It takes 2 or 3 hours for them to cross. So last night there were 2 at the same time and the Great Red Spot. And I got to stay up late and take a look at all those 3 crossing at the same time.
Oh, that's
It's amazing.
amazing. I would love to see that view of Jupiter again that Claudio shared. That was, I believe, taken last night. I think it's cloudy out where Claudio is right now, but this is using his setup with his telescope and his camera. So we're seeing a view just through the telescope. And what I think is amazing is night to night to night, if you go out and look at Jupiter, which is stunningly beautiful in our sky right now, you can actually see how the moons are moving, like you said. So it was different last night than it is tonight. And you can see Jupiter's 4 largest moons. Right now, Io is the only one we can't see here. We can see Europa, Ganymede, and Callisto.
Yeah.
I'm going to take a look and see if we have any questions coming in. Looks like there are lots of comments. Oh, we have a few questions.
Yeah.
Oh, a few
I
questions.
actually have a.
Yeah, go ahead, Rochelle. I'm going to take a look at the questions.
Yeah.
Go ahead.
I have a question, and it might relate to Li Gang's question about Saturn. How do you know that you're looking at a planet and not a star when you're looking at the night sky? Because they're so bright.
That's a good question.
Mm-hmm.
I have a technique, and then Chris, I would love to hear your technique. I know that there is a song called Twinkle Twinkle Little Star, but there's no song called Twinkle Twinkle Little Planet. So that's what I always remember. So if I'm looking at something that's very bright in the sky, and I'm not sure if that's a planet or a star, I try to keep my eyes open and see, is that light quite steady, or is it twinkling or flickering? And if it's quite steady, I think it's more likely that it's a planet. And then I often will take out my cell phone, which has an app on it that tells me what's up in the sky. And I could be like, oh yes, that is indeed a planet that I'm looking at. What about you, Chris? You're quite well versed in sky watching, so I'm sure you know where most of the planets are and when they're up.
Well, from Canada and the GTA, of course, we actually sit north of the equator on the Earth. So for us, all of the planets are always in the southern half of the sky for us. And they're always distributed along the ecliptic, which is the plane of our solar system expressed across the sky. And so if you get a sense of where the ecliptic is, obviously the sun is on the ecliptic, the moon and the planets all journey along it. So you get to know after a while, which strip across the sky the planets are allowed to be in, and that gives you a better sense of them. Certainly, if you were to turn around and face north, and you saw something bright, chances are it might be the space station or some other bright object, not a planet.
That's a good point. There's lots of bright things in the sky that might not make it obvious that what you're looking at, the space station being one of them, because the space station can get almost as bright, if not brighter, than Venus in the sky at times. Is that right, Chris?
Oh, exactly. Yeah. Yeah, no, it varies in brightness according to the geometry with the sun, but it can definitely outshine all of the other planets on a good pass.
Yeah, and it is moving really fast too. It goes around the Earth once every 90 minutes or so. So yeah, I think it's fun if you're devoting your time to stay out on a clear night and look up, and if you know there's going to be a pass overhead of the International Space Station, it's fun to stay out for more than an hour and a half so you can see it go by twice. We have a question from Stems Sin Fronteras. What is Jupiter made of? Rochelle, do you want to take that one? trying to remember. Jupiter is mostly like most of the gas giants. Most of the gas giants are hydrogen.
Yeah, mostly like our sun, actually, which is kind of an amazing thing. They say that if Jupiter had become more massive than it is today, our solar system likely wouldn't be what we know it now today. We would be in, we'd have like a smaller companion star in Jupiter orbiting our sun. Our Jupiter, as far as I know, is like mostly hydrogen, helium, some methane, and ammonia gases. So, and it's really neat because it doesn't have a solid surface, which is why it's like called a gas giant. Unlike the four interior planets, the four planets closer to the sun, Mercury, Venus, Earth, and Mars, which are the rocky terrestrial planets. There's another question here. I think it's from Walt Gao. Is it cold on planets?
Depends which planet you're on.
Yeah.
It's cold in space, but then depending on the planet. So, for example, I'm trying to remember our later trivia. I don't want to give anything away. I think this is safe to say that it is very hot on the planet Venus. Venus is the hottest planet in our solar system. It's hotter than the inside of a pizza oven, over 400 degrees. So it's very, very hot on Venus. It can be moderate at times on Mars. The highest it can get to is around 20 degrees Celsius, which doesn't seem to be so bad. But then it gets down to a nice minus 200 or so at times, minus 180, I think, around there. Chris or Rochelle, correct me if I'm not. It might even be colder than that, I think. But yes, so it's the further out you go in our solar system, the colder it's going to get. So we've got Mars, then Jupiter, then
I think Mars, you might be able to get away with a parka in some places, but after Mars, it's spacesuits all the way from there out.
Yeah.
Parka with a helmet and an oxygen tank.
Exactly.
Yeah. But I think I understand Mercury can get very hot when it's one side is facing the sun, but because it has no atmosphere, nighttime on Mercury can be very, very cold.
Exactly.
Is that right?
Yeah, that's absolutely right. I think nighttime on Mercury is the largest temperature swings of any planet in our solar system. It gets to be very cold on the nighttime side of Mercury. Chris, I got a question here from one of our viewers, Rob Asylum. For an amateur sky watcher, what do you recommend to look for in a telescope when you want to see planets?
We could spend all evening talking about picking a telescope. The few things that you've got to think about are how portable you want it to be and what objects that you want to look at. And you've indicated planets. So planets are bright, so you don't need a lot of light gathering in order to see them clearly. So most people can get away with a modest size telescope. You can get a telescope that uses a lens at the front. That's called a refracting telescope. Or one that uses a mirror, and that's called a reflecting telescope. Refracting telescopes tend to be smaller, narrower diameter, more compact. And for most people, something like a 70 millimeter aperture or an 80 millimeter aperture would be certainly perfect for the moon and planets.
Those are great tips. I believe that, Chris, you have some advice and tools for helping people spot where the planets are in our sky right now using the Stellarium software. Is that right?
Sure. I think let's give a quick summary of what's happening in the sky right now. I'm at my desk where there are never any clouds. This is fantastic. So I'm using this software program called Stellarium, which we love in the RASC and the Science Center because it's a free open source program that anybody can run on their PC or their Mac. And there are even versions for tablets and smartphones. So this is Stellarium. I have it set up for the Toronto area, and it's showing the sky right now. And I mentioned that that strip across the sky called the ecliptic a little while ago. That's the yellow line that I have labeled on here. That's actually the path that the sun travels through the sky due to Earth orbiting the sun. And as it does so, it visits all of these constellations that are scattered along the ecliptic. And as I mentioned, the planets are always in the same vicinity. So here's a live simulated view of the sky right now outside at just before 9 p.m. Eastern time in Toronto. And you can see we've got Saturn and Jupiter sitting together in the sky. Jupiter is quite a bit brighter than Saturn, but they're both very, very noticeable. And you can actually see that they're rather close together. They're actually going to spend all summer within about a fist's diameter of each other. Right now, they're sort of 8 degrees, which is a bit more than a palm's width apart. And because Jupiter has a faster orbit than Saturn, then next year, Jupiter's going to hop and sit on the other side of Saturn. But for this year, for all summer and fall, they're going to remain together in the sky. And you can see them as soon as it gets dark. They're bright enough that they pop into view as soon as the sky begins to get dark, and they'll last until about 3 in the morning. So you've got quite a number of hours in the evening to take a look at those. We'll look at some close-up views of Saturn in a little while. And I'm going to bring up a little time machine control here and advance the time. So you can see I've got August 15th, 2020, and the current time of 2058, which is 8:58 p.m. And if I hop a couple of hours forward, you can see I could pick up the planet Neptune. Neptune, you need to know a little bit more help of where to find that. It's not a bright naked eye planet, but you can certainly see it in a backyard telescope if you know where it is. And then here in the eastern horizon around just before 11 p.m., you can see Mars popping into view. So Mars, once it rises in late evening, you've got all night to look at it. And we're going to have actually better and better opportunities to see Mars over the next 2 months. It's going to rise earlier and earlier and be sort of available right at sunset. And then if we keep going a little bit further, we've got Uranus. The planet Uranus is definitely naked eye visibility from, say, a cottage, rural location when the moon is not too bright.
Oh, really?
And it's sitting here. The trick to finding Uranus is to look for, well, you can use Mars to help you, because Mars and Uranus will be roughly this arrangement for the next few weeks. And then you can look for these 2 bright stars in the constellation of Aries the Ram. This is Hamal and Sheridan. And it's sort of a skinny triangle right below them. You can try to find Uranus. Uranus will have a nice blue-green color, and it won't twinkle as much as the stars around it, as Rachel alluded to a little while ago. And just to wrap up our little tour, if you're an early bird and you're up in the middle of the night, you can start seeing the winter constellations appearing in the sky. And then around, let's see, about 2:45 in the morning, super bright Venus will pop into view, and it'll stay visible almost until sunrise, because it's such a bright planet that even the dawn sky needs a while to hide it.
The morning star.
Yeah. Right now it's the morning star. Yeah, we had a long period earlier in the year where it was an evening star. Now it's become a morning star, as we say, for a while. And then down, I think we've got Mercury. Where's Mercury? Just above the sun. So Mercury's lost from view right now. But Mercury is a pretty speedy little planet. About every 44 days, it flips between the morning sky and the evening sky. And so in a few weeks, it'll join the evening sky, and we might be able to get a look at Mercury. So
something to keep an eye out for.
Yeah.
Mercury is also a naked eye object, but it's tricky because it's so close to the sun, right?
They're actually, as I said, because it's every 44 days, we've got different types of appearances of Mercury during the year. 7, 8 different views of Mercury during the year. So the next one in the evening sky is not going to be a very good one for North American viewers. But then later in the year, we'll have some really excellent opportunities to see it.
Chris,
That's
could you
awesome.
repeat the time that Mars will be rising tonight?
Yeah,
For
Mars is going to rise just, I think around, let's see, 10:48, just before 11 p.m. But really, you need to give it a good half an hour or an hour after it rises before it sort of clears the houses around you and the trees and gets high enough to see clearly.
We have a question from Lee Gang. How does Mars look like in the night sky? So if you were to look at it maybe with the naked eye, and then what does it look like through a telescope? Well, we might see what it's going to look like through a telescope a little bit.
Yeah,
later. We might have something we could share. But
I looked at Mars last night.
Yeah.
I was up late. I had my telescope out looking at the shadows on Jupiter, and I thought, oh, what's that bright red object that I noticed through the trees as I was getting ready to pack up? And that was Mars peeking through the trees and catching my eye. Mars is gets prominent about every 2 years. And this is the year where we're going to have a terrific show of Mars come October. But even now, it's starting to get nice and bright. So as I said, in late evening or around midnight, if you see something bright and reddish tinted in the sky, there's really nothing else around it that's nearly as bright. You can be pretty confident that that's Mars.
We've got a lovely view from Claudio's telescope here, both a video and now we're seeing a processed image. How stunning is that? You can see the red color of the surface of Mars, the detailing of the different types of terrain and surface. You can also see the white on the bottom. Any guesses as to what the white on the bottom is? Maybe put it in the chat. We'll talk about Mars a little bit later. I know that, Chris, you had some more tips on, if you don't have the computer with you or the Stellarium app, you have some advice for how to use something that looks a little bit like this.
That's a Starfinder, yes. So what a Starfinder is, it's a virtual sort of an analog planetarium, and it's generally composed of two pieces. The first piece is a star wheel, and the star wheel is showing all the stars that would be visible in the sky from a given latitude. This one's made for Canada, so it's around 40 degrees or 45 degrees northern latitude. But on a given night, you can't see all the stars that are possible in the course of a year. And so what this little container, this little holder does is it puts a window that limits the stars to the ones that we can see on a given night. And the way that this works is that you have hours of the day, so you can set up the time that you're observing, and it's got dates of the year. And if you line up the date with the time you're looking, say 9 p.m. on August 15th, then the window will then be limited to just the stars that are visible in the sky. So I'll just sort of do that. Now these paper starfinders don't show you where the planets will be because the planets are constantly wandering around. So they're basically designed to concentrate on the stars and the constellations and some of the deep sky, nebulas and clusters that might be in there. And you can also see there's a bright patch that shows where the Milky Way would run across this. And if you want to get your own Starfinder, you can, sometimes we hand these out at our RASC or Science Center star events once COVID's done. But you can also make your own. Let me just bring up my screen here, and I'll show you the page where you can get a hold of one. So this is the RASC national website, rasc.ca/starfinder. If you go on here, you've got a video that'll teach you how to use it. And then if you click the download button, it gives you the opportunity to download a PDF that you can print and then cut out and put together yourself. So there's an English version and a French version. And I'll just bring up the version here.
This is great. And then this can work all year round. So the next time we're all able to be together, perhaps some of you can bring your own printable homemade Starfinder as you join us.
Exactly. So hope everybody goes ahead and gets that.
I think that is great. Thanks for sharing that, Chris. And we're going to put the link to the RASC's website that you just shared in the chat for anyone who's interested to download their own at home. And you mentioned that'll help us spot stars and constellations, not so much planets, but it does have that ecliptic line there. So it can give you a sense of where to guide your eye. And if you see something really bright along there and it's not twinkling, it's probably a planet.
And if it's not on this, if it's not on the star wheel, then it must be a planet.
Yeah. That's a good point. Rochelle, you have some tips for us on on constellations and spotting constellations in the sky, and also star hopping from star to star in our sky, don't you?
Yeah, because, when you're doing a star party or when you find something really cool to look at in the sky, you want to tell your friends. But sometimes it's hard to, figure out where everything is. And if you don't have your star finder with you and you are familiar with patterns, you can use the ancient technique of using your hands as a frame of reference. If you extend your hand out in front of you and look at the sky, you can think of yourself at the center of a giant hemisphere. And of course, we can measure a circle in 360 degrees. By sticking your hand out in front of you at arm's length and just making different gestures with your fingers, you can approximate the different degrees and the distances between different objects that you found and different stars and different constellation patterns that you might be more familiar with. So for example, as you see on our page here, if you stick out your pinky finger, the width of your pinky, now of course everybody's hand is slightly different, but it should be approximately about 1 degree. And you'll notice that if you see the moon out there, stick your finger out, look at it, and the moon is almost, it should be completely covered. By putting different fingers together, you can estimate the different degrees. So for example, if you make a fist with your hand, that represents about 10 degrees. And you might be able to fit it in the 4 stars that make the bowl of the Big Dipper. And if you make the rock-on symbol, you might find it just fits within the distance between the 2 stars, Deneb and Vega, in the summer triangle. They're 2 of the 3 brightest stars of the summer triangle. And then of course you can use your hands and combinations of fingers to move from familiar pattern to familiar pattern. It's the way our ancient ancestors, thousands of years ago, would have looked at the night sky to make sense of the things that they were looking at. And you can do it too. Now, what I think is really fun is about the constellations is you got to get used to looking for the brightest patterns. A lot of the patterns of that we think of as familiar today would have been named by our ancient by people from generally the Greek and Roman mythologies, but every culture around the world had different names for the different star patterns and the specific stars of interest after their myths and folklore and whatnot. And so these are things that have been passed on to us, and today we use them, of course, to map out the night sky. So I'm just curious, for people out there, maybe you have a favorite pattern or constellation that you want to share with us in the YouTube chat. You can just write that there, and maybe you can tell us why. And if you know names of stars, maybe you can put that in the chat too and tell us, why are these constellations interesting to you?
I love that. That's such a great question, Rochelle. Love to hear from our audience of what their favorite constellations, those patterns that you can see by connecting the stars in the sky. Maybe your favorite constellation is one that's not an officially designated constellation. It's one that you created by connecting the stars in your own way, and that's totally cool. I want to go back to some of the questions we posed to our audience earlier because we've gotten some answers. I posed the question, what is that white stuff that we can see in that image of Mars? Very popular answer was ice. And yes, you're all correct. Someone had suggested that we have Rickroll suggested that it's probably a polar ice cap like the Earth's ice caps. And yes, you are correct. The south pole of Mars, there is so you have a lot of frozen carbon dioxide in the ice caps, but you also do have frozen water ice in the ice caps on Mars as well. And we did have an earlier poll about what your favorite planet was, and we have a winner. We have, drum roll please, the most favorite planet as voted by all of you is Earth. Home sweet home. Runner-up, any guesses to what the runner-up would be, Chris and Rochelle?
I want to say Mars. It shows up a lot in the questions. Like, people want to know if we can actually get there one day.
Yeah.
Maybe even inhabitable. I don't know.
Spot on. Yep. Runner-up was Mars. And then in third place, Old Faithful, the standard, Saturn. One of my favorites to look at in the sky with those beautiful rings. Rochelle, I believe you have a joke about Saturn.
Oh, you're going to make me do it, really?
I love that joke.
Okay. Does anybody know what Beyonce's favorite planet is? Yeah, it's Saturn because someone put a ring on it.
So I've got a cool fun fact about Mars that has to do with the polar cap. So Mars has a tilt on its axis, just like the Earth does. And so it has seasons, just like the Earth does. And actually, winter just started on Mars on September. We'll start on Mars on September 2nd, just a couple of weeks from now. And that means that the southern polar cap of Mars is more tilted towards the sun and then more visible to us on Earth.
That is a fun fact. I had forgotten that Mars was in a different season from us. One thing that's really interesting, I have some friends who work on the various Mars missions, the rovers that travel to Mars. And when they first land and if they're working with the rover, they have to like set their clock to Mars time. So they have to be on the Mars day, which is pretty close to an Earth day, but it's not quite exactly right. So sometimes they might have to be up in the middle of the night on Earth because it's daytime on Mars. And so that's kind of a cool thing that if you are a scientist working on a mission to Mars, you have to work on Mars time. Seeing some favorite constellations up here. We've got Maxine says Ursa Major. We see Orion. Oh, Orion is my personal favorite. I think that Orion is my favorite because I think it was the first constellation I ever saw, and it was pointed, and he said, that is the constellation Orion. And I called to my brother, hey, Ryan, come here. There are stars in the sky named after you. And that memory sticks so strongly with me. Of course, Orion and Ryan are different, but in my young mind, they were the same. And so that's one of the reasons why that one, I have fond memories from my childhood looking up at that pattern in the sky, but also there is so much cool stuff happening in Orion, and I'm kind of bummed we can't see it right now because it's a winter constellation. We only see it up in the winter months.
But just get up early.
That's true. I am not a morning person, though. I'm an astronomer. I'm a night owl. I like to stay up late.
Well, what you can see tonight, opposite Orion, of course, is Scorpius and Sagittarius. Those are, I think Sagittarius has got to be my favorite. It's a big constellation, but there's a smaller pattern of about, I think it's 9 stars that make up a teapot shape.
I've got it up on Stellarium now if anybody wants to see.
Yeah. So if you're facing the southern horizon and you look up and see that teapot shape and follow the spout of the teapot, it's kind of like the Milky Way stars look like the steam of the water that you're boiling for your tea. But that spout points us to like the most mysterious but possibly fantastic object in our galaxy, that great big black hole Sagittarius A star. We can't see it, but at least I know how to find it.
We have Kenneth has also said Sagittarius is their favorite constellation. We've got a lot of votes for the Big Dipper. Big Dipper, an asterism in the larger constellation of Ursa Major. Very recognizable pattern of stars, very popular, especially for anyone in the northern hemisphere. Really easy pattern to spot. Big Dipper goes by many, many names as well.
Rachel?
Yeah?
do you think we can see some stars through the telescopes right now?
I think we can. That's what I was going to take a look at next. We've been talking a lot about constellations and stars. I think that's a perfect segue to take a look at some stars through telescopes. So Chris, you've been sharing some awesome views through stellarium. We're going to take a look through those telescopes at some stars right now. And we're going to talk double stars. Double stars are views where you can actually, it looks like there are two stars together as a binary pair. Some of the ones that we're going to look at are not true binaries. They're optical binaries. And so what we're seeing here now through Blake's telescope is the bright double star alberyl. This is one of my favorite objects, I must say, to look at through a telescope because of the striking difference in the color between those two stars. You can see there one looks very blue and one looks a little bit more orangey red. That is really beautiful to see. And so this is an optical double. So this is not a true binary star. It just is two stars that appear to be close to one another along our line of sight. Now we're looking at another double star here, Alpherk. We can see. Sorry, go ahead, Chris.
No, I was just confirming what the star we were looking at was.
I think it's in the constellation of Cepheus.
Let's get that set up here.
And we have got some questions coming in. The color of, we got some different colors seen here. Sorry about that. Just trying to find what word. So yes, so we're looking at those. So the two stars that you saw, alberyl. So the colors are different because of where the stars are in the stage of their evolution. So stars that are very young, hot stars, the blue is an indication typically of their age and their temperature. So if you think about like a campfire, the hottest parts of the fire are where the flames are blue or white. And then the sort of parts of the fire that are maybe not as hot are sort of where it's more red or orange. This is the case for what we see for stars. Stars that are red or orange are much cooler on the surface than those which are blue-white. We see many red stars in our sky. In the summer sky, we've got Antares in the constellation of Sagittarius, of Scorpius, pardon me. Yeah, thanks, Rochelle. And Arcturus is another red star. And then lots of blue stars. I believe Vega is a beautiful blue star. Here's another double star that we can see here, 61 Cygni. So what's amazing to me is that you can actually see these stars are so close together that you can see them through the eyepiece of a telescope. Typically, that's not the case. When you look up at like constellation patterns in the sky, those stars are very far apart. So these binaries, whether they're optical or not, must be very, very close to be viewed in the same eyepiece.
So that Gamma Delphini star is really interesting. So the astronomers have now determined by studying the relative motions of the two stars over many years that the one star is orbiting its companion. And the orbit is very elliptical. And in fact, there are times when the two stars are only very close together, only 40 astronomical units. An astronomical unit is only the distance from the Earth to the sun. So if you can imagine two stars being only 40 times that, that's crazy. That's like having another sun out past, out sort of in the Pluto range of the solar system. But then at other times, At other times, those two stars are up to 600 astronomical units apart. So it swings in rather close and then swings out. And it takes about, I think, about 3,200 years for an orbit to complete.
Chris, we got another question about a telescope. Shi Wang asks, where is a good place to buy a good telescope?
Well, in the GTA, a lot of the astronomers that are buying in the GTA are avoiding places like Canadian Tire and Walmart and the department stores and favoring our local sort of astronomy specialists, our nature, our birding shops and our astronomy shops. And a very good one is KW Telescopes in Kitchener. There's a gentleman that has a shop in Bolton called Ontario Telescope. There's Conscope in the Toronto, down sort of near Yorkdale Mall. And there's a gentleman in Pickering called, I think it's, I forget the name, but I'll think of it.
Durham
and I'll come back
Skies,
to it.
I think.
Durham Skies, yes, yeah. Durham Skies. Thank you. So those are 3 or 4 vendors that are distributed in the GTA, which are highly reputable and recommended by the astronomers that that are members of RASC and the Science Center. That's
a great tip.
A lot of people, oftentimes when I have a planetarium show, people ask the same question. But I like to recommend not even starting with a telescope. I think binoculars are a good way to start. If you want to get close up, first you got to get familiar with the sky. But binoculars can help you get familiar with the closer objects. Like you can get really good views of the moon. If you have binoculars that are, say, I think it's 15 by 70 magnification, you might have to use a tripod to keep it steady. But the bigger your field of view, so what you're looking at, the more light you can let in, you can actually start to make sense of what you're seeing. Because Chris, doesn't it really depend on what you want to look at, like what and how much you want to invest in something? And there are different types of telescopes that you will purchase for different objects.
Yeah, so the important aspects, as I said earlier, is the aperture, which just dictates how much light that the telescope can gather. The bigger the aperture, that means the more light it collects and concentrates all that light into your eyes. So if you want to look at dim objects like nebulas and galaxies, then a large aperture telescope in the 6 inches in diameter or 8 inches or bigger would do that job for you. But that tends to be beyond what beginners want. So as I said before, if you go with a 3-inch or 80 millimeter or 100 millimeter refractor telescope, that'll be perfect for the moon, for planets, and for the double stars, and even things like the Andromeda Galaxy I see that someone's asked about. So I would go with that. And the other thing that's a lot of people like to jump in and get a computerized telescope. And I discourage that, because if you want something that you can pick up, carry outside, set up and start watching, then you want something manual. If you get a computerized one, you could be half an hour before you're ready to go. And so, that's great if you're dedicating a whole evening to it. But if you wanted to be a little bit more spontaneous, then maybe consider getting something a little more basic and old-fashioned, but that works great, and you can use it in a flat, instant as soon as you're ready to look.
That's a great tip. I see from Claudio that he is live on Jupiter right now, so I would love to take a look at Jupiter. All right, let's see. So we are looking at Jupiter from, I believe Claudio is in Newmarket. That is awesome. So what we're seeing right now is a view. Claudio has a camera mounted to his telescope at his home, and he's sending that view through his computer to us to be able to see. So this is just very similar to what Jupiter would look like if you were looking through this telescope with your eye. And so you can see there, very fortunate, it's peeking through the clouds.
Yeah, that'll make it go dim and bright as the clouds sort of pass in front of the telescope.
Yeah, so not going to see it as detailed as we did in that recording that was shared earlier, where we were seeing that processed image. But this is really cool because it's giving you that feeling of what it would actually be like to look at it through the telescope live. So we're seeing that view right now.
So
It's disappearing.
the great red spots there, the great red spots near the edge of Jupiter right now. If anybody has a telescope and they're able to have clear skies, take a look because you can catch the great red spot tonight.
That's awesome. Thanks for sharing that, Claudio.
And another really cool thing that I was going to mention earlier about Jupiter, even though it's made of gases, it's not gaseous. So the amount of sort of gas component of Jupiter is not much thicker than Earth's atmosphere by proportion. So if you can imagine a layer of gas similar to Earth's atmosphere around a more solid ball of gas, that would be more what Jupiter is like.
Wow, that's a really great way to describe it. It gave me a really sort of nice feeling and a good sense of it. It was a great visualization. We're seeing, you mentioned, Chris, that we've seen some questions about Andromeda. I don't think we're going to be able to see Andromeda through the telescopes tonight. It is pretty cloudy out there, but we will later this evening towards, let's see, let me tell you what time it'll be. We're going to shift to some deep space objects. So we've been talking a little bit about planets. We've been talking a little bit about stars. In about 30 to 40 minutes or so, shortly after 10 o'clock when it gets a little bit darker, we're going to try and target a few deep space objects, some nebulae, some star clusters. So stay tuned for that. We've been talking quite a bit about stars, and I want to transition to some events that have been happening in the sky lately that some of you maybe were wondering about. Maybe some of you had a chance to see them. And these aren't stars, these are shooting stars, some more transient objects or events that are happening in our skies this month. They, of course, happen over the course of every year and any given night. You may see a shooting star, and you can see one there in that image. This is a Perseid meteor that was captured, and I'll talk a little bit about the Perseid meteor shower shortly, but I want to mention that you don't necessarily have to wait for a meteor shower or an event like that to spot a shooting star or falling star. They happen every night, especially if you're in a dark sky location. You can start to see on average maybe about 8 per hour on a given night. That's if you're in a pretty dark sky location and you're looking up for a long period of time. But we always have debris falling to us on Earth. Most of it burns up in our atmosphere, like we're seeing in this image here. So shooting stars, falling stars, meteors, whatever you want to call them, all the same thing. It's falling pieces of debris, space rock, burning up in our atmosphere. If you rub your hands together really fast, you'll feel they start to warm up, and that is because of something called friction. And so as the debris falls or rains down on our planet, we can see those stars or those pieces of space rock appear to streak across our sky. And in some cases, you get some very spectacular objects blazing across our sky, such as the one that we can see here. So this is a fireball. This is shooting across our sky. In fact, as you can see from this image, perhaps it is even a bolide. The difference between the two, fireballs are meteors or shooting stars that streak across our sky and are very, very bright, brighter even than Venus. A bolide is an even brighter shooting star that actually can explode in our atmosphere. What's amazing about this video clip, this is taken by an all-sky camera that's mounted on the roof of McMaster University in Hamilton. This is a view of a fireball shooting across the sky in September of 2009. This is an event that was spotted by many people, and we can see Let me just play that one more time. Just go back. Here we go. You can see it again. And comes flying in. This was recorded. The sighting was seen by many people. And because there were so many reports of this shooting star, they could actually track its location and determine where it landed. And they found the debris strewn field of all the meteorites that made their way to the surface of the Earth, survived that trip through our atmosphere, and the strewn field was found in Grimsby. So a lot of those meteorites ended up being collected, and the specimens have been studied. And so that is one example of what a fireball can look like in the sky. And if you happen to see a fireball in the sky, you can actually contribute to citizen science through the American Meteor Society. They love to know and track these different events, so you can report a fireball. We can put the link for you in the chat there for the American Meteor Society. They have a really straightforward reporting form that you can just enter, where you were, what direction you were looking, roughly how bright the object was in the sky, how it moved across the sky, and it's really interactive and intuitive. So it's really fun, and it's a great way to contribute to citizen or community science, something that I always enjoy doing as well. So after those meteors have made their descent to Earth, what's left behind are certain things on the surface called meteorites. And we often get asked at the Ontario Science Centre, we get a lot of questions about, hey, I think I found a meteorite. Can you identify it for us? And some of our colleagues over at the Royal Ontario Museum also have in the past run an ID clinic for meteorites. So there's lots of places in the city where you can go to find out information about whether or not you found a meteorite. I have a few meteorites here I'd like to share. And I also want to share some tips with you as to whether you have a meteorite or a meteor wrong. So let's take a look at those. So one of the first things is it heavier than it looks? Now meteorites like this one that I'm going to show you here. So this is an iron meteorite. Meteorites typically come into 3 categories. So you can see the shine on that. So it's iron meteorite, very metallic sheen to it. Much heavier than it looks. Typically, if you pick something up and for its size, it feels a lot heavier. That indicates that there's a lot of metal content in it. So that's one of your first clues that what you have might be a meteorite. Second clue is it attracted to a magnet? And so I have a kitchen magnet here, and we can see, yes, indeed. So it is attracted to a magnet. Another thing to look for is, are there thumbprints or reglins? It's a tricky word. I like to call them thumbprints because a little bit easier, but there's these indentations that you can see on the surface of the meteorite, and it looks like little thumb indentations, kind of like if you were molding something with clay, and as you were molding or shaping and forming the clay, you were leaving little thumbprints in it. And that feature is often seen in these iron-type meteorites. So you can see that there. That's a feature as a result of the rock falling through our atmosphere, there being some melting occurring. And then this is a case. This last one I'm going to mention is, does it look like a charcoal briquette? Now, you might think, well, that one that Rachel was just holding up doesn't look like a charcoal briquette. That looked like a shiny piece of metal. It also might look a little bit similar to magnetite, earth rock. So that one is often mistaken as a meteor wrong, magnetite. But this one, iron-type meteorite, we compare that contrast that to a stony type meteorite. Now this might look just like a rock. These are actually the most common type of meteorites, pardon me. But they tend to blend into Earth rocks a lot more. It's a little bit trickier to identify, still a little bit heavier than it looks, also magnetic. So you can see that there. But you see, I mentioned that charcoal briquette. So see how black it is there on the back as compared to the other side? So it looks like it has this crust. So that's called a fusion crust. That's a result also of the rock burning up through our atmosphere. And this one is a chondrite, a type of meteorite, and you can actually see some detailing inside the meteorite there. Hopefully that's focusing for you. And so these are two examples of a stony type meteorite and an iron type meteorite. And in the image on my slide, I'm also sharing an image here of the third major category of meteorites, which is stony iron. So not too creative with the naming, but we tell it like it is. Stony iron, stony iron. And this is a beautiful specimen. This is an image that I took at the Natural History Museum in London of a beautiful palisite. And you can see those green crystals. And that is actually a crystal called olivine that's embedded in nickel and iron. So you can see that there in that beautiful stony iron meteorite. So those ones are the least common. So those are certain things to consider if you think you might have a meteorite. So if you find that it has several of those, you've answered yes to several of those questions, then you might be in luck and you can contact maybe a local university to find out more details. Most don't do appraisals for the value of meteorites, but they can help you identify whether or not it is for certain a meteorite. So something to consider as you hunt for those fallen objects.
Rachel, there are a few questions in the chat for you about your talk.
Absolutely.
So I think somebody called You Know Me. If you find a meteorite in the wild, is there a possibility that it can be dangerous to touch or toxic? Because we notice you're using gloves to hold them.
No, so I could pick these up with my hands. There's no danger to them. I'm just wearing gloves just because we try to be careful with any museum samples that we have here. Most artifacts we like to handle with care because it's not that it's harmful for me, but like the oils in my fingers could damage the meteorites and want to keep them in the best condition possible. So not at all harmful in any way. Sometimes when we take these out to share with visitors on the Science Center floor, we've had people smell them because they feel like they want to know what space smells like. I know there was a couple questions in the chat asking, what does space smell like? These rocks just kind of smell like rocks. They don't smell like anything special, but I have heard from some astronauts who've been on the space station, they have shared in some talks that they've given that space can smell a little bit like gunpowder or like a burning smell, like if you have ever burned something on the stove or on a barbecue. And they can't smell that when they're actually out on spacewalks because they have their spacesuits on and their helmets on. But when they come back into the space station, they can smell their spacesuits, and it does have a scent to it. And that's something that they've commonly shared, that there is almost like a smell, kind of like burning. That might be due to there being a lot of carbon. Most meteorites I've mentioned here have a lot of iron. Almost all have nickel, but then we have things like carbonaceous chondrites. So it's a category of meteorites which are very carbon rich, and there is a lot of carbon in our solar system, that element that is the sort of building blocks of life, and so carbon might be what's giving giving rise to that smell that we we sometimes hear about in space. But no harm to the meteorites. If you were to come up and approach them, most likely they would be. They don't think they would be hot to the touch anymore. I'm not sure. Chris or Rochelle, are you familiar with whether they would likely cool very, very quickly once they reach the surface of the Earth?
And they would have been cold on the inside before they fell as well.
Yeah, absolutely.
So it's
yeah,
kind of a trade-off.
Yeah, so it might be room temperature by the time it reaches the Earth. The coolness of space, the warmth of the atmosphere, bringing it right up to temperature that you can touch and take home with you. So I mentioned at the beginning, you can see sporadic meteors on a given night. And then you have meteor showers that happen several times throughout the year. And we are actually in the middle of one now, the Perseid meteor shower, which had its peak just a few days ago. So it's tapering off. Not going to see really as many over the next week or so. So if you're a really dark sky and you look towards the northeast, you might spot a few objects streaking across the sky, but you're probably in the same range of having the same kind of luck as you would if there were sporadic meteors, because we're just going out to the tail end of the Perseid meteor shower. But this is an image of kind of what like a meteor shower might look like. All those meteors falling to Earth, and often cases many at a given time. So you have a much higher chance of spotting a meteor when there's a meteor shower. And one event that occurred quite a long time ago was quite significant because meteors were actually thought to be originally an atmospheric phenomenon, not of space origin. And that's, if we think about the term meteorology, or so the study of the atmosphere, the study of weather, that's why when we talk about shooting stars, and the word meteor does mean high up in the air. So it was thought to be a phenomenon similar to lightning. And it wasn't until 1833 when there was a meteor storm. This has been recorded as the night the stars fell. This is a very famous engraving that you can see here. Based on a painting by a Swiss artist, Karl Jalslin. And this shows a sense, just a feeling of what it might have been like in this moment on November 13th, 1833. This is a very famous Leonid meteor shower that happened in November of that year. The Leonids happen every November, but not everybody knew this at that time. Many came out of their homes thinking that the sky was falling. You have hundreds of thousands of meteors that were falling to Earth over the course of that night. And this is a much higher rate than anything that was seen around that time. And there was an astronomer named Denison Olmsted, and this is a story that I really love. And he came out of his home, he saw all these people coming and observing the sky, and they were all observing the sky together. And he wrote a story for an article, and when it ended up being published in a national newspaper, and he was asking people, can you send me a record of what you saw? I'd like to learn more about this event. And this was the dawn of citizen science or community science. This was one of the first events that actually use crowdsourcing to help learn something about space. And we know amateur astronomy today has grown and grown and grown so that amateur astronomers can make amazing contributions to science and have publications in academic papers. And a lot of community science started with this event in November of 1933. This event has been recorded and observed all across North America. There are records, winter counts in this that are kept in the Lakota calendar, and there is a based in those winter counts, there's actually a record of the year the stars fell. And so using that note allowed the ability to calibrate those winter counts to calendars to get an understanding of the history and records, so we can understand that how many different people were seeing it and many people were keeping the records. So it's important to keep a science notebook and to take records of what you observe and see in the sky, because it could change history. And in this moment, all of those notes came through. Olmsted gathered them all up, and when he got all of this feedback from people saying, actually, you know, we see this event happening not to this degree, but every November, he pieced together that this is actually of space origin, that these meteors were falling to Earth not from within our own atmosphere, but beyond our atmosphere. And this is an image of a Perseid taken by astronaut Ron Garan from 2011, as seen from the International Space Station. So you can see a Perseid from space there, the thin bubble of our atmosphere surrounding our planet as it burns up. And so you may have noticed in that image I shared of the Perseid meteor shower that all of the meteors appeared to come from the same point in the sky. That point is called the radiant. And so it looks like all of the meteors are streaking out in many different directions. And so in the case of the Perseids, they're named as such because the radiant, the apparent source of the meteors, is found towards the constellation of Perseus, which happens to be in the northeast right now. The next major meteor shower is the Geminids, which is happening in December. The peak is around December 13th this year. And they have a similar rate, a very high rate of meteors per hour. You can, if you're in a very dark sky location, you can maybe see 100 meteors per hour in the Geminids. And then maybe as you get closer and closer to a city, you may see fewer and fewer because of light polluted skies. But one thing to note is that does get a little bit cloudier and the weather's not as great in the winter months. So that's why the Perseids are often a great event to watch for. But the Geminids, with the moon being only 1% full at that time, will also be a really great view. And so as you can see, so they all seem to be coming from the same source. Well, why is that? That is because the Earth is plowing through this dusty debris that is left behind by the tail of a passing comet. The progenitor, the source of the Perseid meteor shower, is the comet Swift-Tuttle. This is a comet that comes from the outer edges of our solar system, swings past the sun. Comets have very long, dusty tails, and just kind of like a trail of breadcrumbs, leaving that trail behind them. The Earth, as it orbits the sun, then passes through that debris trail left behind by the tail of a passing comet. And as far as we're concerned, kind of like flies hitting the windshield of a car, they all seem to be coming from the same direction. And so you can see the Earth is moving in its orbit around the sun, and we have that debris left behind by Comet Swift-Tuttle, and it all falls and rains down on us from our solar system. Now these comets, I've mentioned they have tails. These tails, they actually have two tails. So this is an image here of a recent comet. I saw some questions about what happened to Comet Neowise, and so we're seeing Comet Neowise here. And then we are actually going to be able to spot two tails. This is a dust tail and a gas tail. The gas tail points opposite the direction of the sun, and the dust tail points opposite the direction of motion. So comets, you can think of them as these dirty snowballs made up of ice, frozen carbon dioxide. They have organic material, a lot of dust, and they live in the outer edge of our solar system. Comet Neowise swung past our sun on July 3rd, and then it was bright in our sky, and then it now is moving out to the edge of our solar system. There are some images that we can see here of Comet Neowise in our sky that have been taken last month. One of them here, Neowise peeking up in the morning sky in early July. And then we have another lovely image of Neowise as seen through a telescope. This is taken by Ward LeGros, a member of the RASC Toronto Centre. So thanks for sharing that one with us, Ward. We also have a beautiful view of Comet Neowise as seen. This is up in New Liskeard. This is taken by a staff member at the Ontario Science Centre. So beautiful, stunning view of Comet Neowise. So if any of you have any images that you were able to capture of Comet Neowise, we would love to see them. You can share them with us on our social media channels. Some of my favorite comets are one that I didn't get to see myself is Comet McNaught. This was a great comet of 2007. It was seen only in the southern hemisphere, so not visible for us in the northern hemisphere, but such a beautiful tail. This image is just really, really striking that you can see. And one that I actually fortunately was able to see, not to this level of detail. This is a beautiful image of Comet Holmes, but Comet Holmes was a bit of a surprise back in 2007, and it had this enormous outburst, the biggest at the time of any in the solar system, and it actually became so bright it was visible to the naked eye, and it expanded out. Even though it was very diffuse, it grew until it was actually the biggest thing in our solar system for a moment in time, bigger even than our own sun. So Comet Holmes was a really incredible event. So comets can be really fascinating, but they're a bit tricky and they're a bit fickle. They're not always sure what you're going to get with comets. So as I mentioned, we would love to see any photos that you may have with us. You can tag the Ontario Science Centre or the RASC on Twitter or Instagram. We're also on Facebook as well, but photo sharing is a little bit easier on those other channels. And I'm seeing that we actually have a live view of Saturn that I would love to see. Looks like skies are clearing up a little bit for Claudio, and yay! That is awesome. Thanks, Claudio, for tipping me off that we were actually going to get to see this tonight. What a thrill. Oh my goodness. One of my favorite things to look at through a telescope. And I love you can see the gap there between the planet and the rings. And really, really clear night. You can sometimes even see the gaps in the rings, can't you, Chris?
Yes, there's a very prominent one called the Cassini division that divides the outer ring from the inner ring. And then our space probes that have orbited Saturn have detected many, many minor gaps in the rings.
That's really, awesome. Really cool. And can you see, I know for Jupiter you can see the largest moons. Saturn has quite a lot of moons. We had some questions about which planet has the most moons in the solar system and how many moons. Saturn, I believe, has the most moons now, doesn't it?
At the moment, Saturn has the record. Yeah, it's up to 82, according to NASA's hot off the press news.
And can you see its largest moon through a telescope, or is it typically not visible?
Oh yes, so a backyard telescope will readily show Saturn's largest moon. That's Titan.
Is that what Titan looks like?
Yeah, we're seeing it.
Cool. So Claudio's pointing that out there. That's actually, yeah. I was wondering that. So I wasn't too sure. I'm like, is that Titan?
Yeah.
Titan
and then you might pick up a few more little dots that you occasionally show up around Saturn. Those are other moons, minor moons. So in a backyard telescope on a good night of seeing, you can see 5 or 6 of Saturn's moons.
Oh, that is amazing.
But Titan's is by far the brightest one. And you know what's cool is that because Saturn has a tilt on its axis of rotation, and that tilt, similar to the Earth, it's almost the same angle as the Earth's tilt. And that means that as Saturn goes around the sun, we see it from different perspectives. And between now and 2025 in the spring, the rings are going to close up. And in the spring of 2025, the rings will disappear for a short while because we'll see them edge on.
Oh, right.
So everybody should get ready for that. And then they'll open back up again.
Cool.
Chris, somebody asked about what telescope Claudio is using for some of the for what we're seeing on this stream.
So
Do you
Claudio
know?
is using, I believe it's an 8-inch aperture telescope mounted on a very precise drive that follows counteracts the Earth's rotation. And the type of telescope he's using is called a compound telescope. It's actually a combination of both lenses and mirrors. And by adding a mirror to a lens combination, you can make a long telescope tube into a stubby tube. And so his telescope would be about 8 inches in diameter, but it would only be about, perhaps 30 or 40 centimeters in length. So it's that would be 200 centimeters or 200 millimeters across and about 4,000 in length. So he folds up the light path inside the telescope, keeps it compact, but lets him do amazing views like this.
That's awesome. We had somebody asking recommended brand of telescope for a beginner. I can note here that for all of our telescopes that we're seeing tonight, all seem to be using Celestron. That's actually the brand of my binoculars as well.
Yeah,
so.
Celestron is a venerable brand. It's been around a long time. Meade is another one. Skywatcher, Orion, Explore Scientific, and then you can get into the Cadillacs and Lamborghinis of telescopes if you want to buy something a little more high end. But those are good brand names to keep an eye out for.
Yeah, that's great.
Where is Claudio located?
I think he's in Newmarket right now.
Yeah.
Claudio's in Newmarket. Francois is in Trenton, and Blake is in Bradford. So that is so exciting. I was so sad that it was going to be cloudy and stormy all night. I'm so thrilled that we actually get to see this live.
So another interesting thing for folks that are looking at the difference between Jupiter and Saturn is that Jupiter orbits the sun and it doesn't have a tilt. So it sits straight up and down in the ecliptic, and that produces the effect of its moons all being aligned in a row parallel to its equator. Whereas because Saturn has that bit of a tilt, the moons can be arrayed above and below and to either side from our vantage point. So that's a cool difference between the way the moons appear from the two planets.
That's so amazing. I think Titan is one of my favorite moons in the solar system. It's the only moon in our solar system that has an atmosphere. And the Huygens probe, which piggybacked on the Cassini mission, actually landed on the surface of Titan. It's the furthest landing we've ever attempted, which is just awesome to me that we've sent something so far out into our solar system to actually land on the surface of a world that's so distant from us. We have another view of another double star. This is one of my favorites, sometimes also referred to as the Tim Hortons star. It is the double spotted in the constellation of Lyra. So Rochelle was talking about the summer triangle earlier. We were talking about the bright stars, Vega being a bright blue star. So this is Epsilon Lyrae. It's quite close to the bright star Vega, which happens to be the brightest star in our summer sky right now. Not the brightest star in our sky ever. I think the brightest star in our sky in the northern hemisphere is the star Sirius, also known as the dog star, and the constellation of Canis Major. But yeah, if you look close to the zenith, nearly overhead, you can actually spot Vega. So you'll be able to see that it's very, very bright in our sky. So that's sort of towards the direction that we're going to be looking at shortly. And we're going to be seeing what's interesting about the Tim Hortons star, or the double, is that you should actually see 4 stars in the field of view of the telescope. So this is a multiple star system where you have 2 tight binaries and then a larger binary star. So we're going to find that view and get that up for you to share. And I think that I have a few questions about meteorites as we're getting have that ready to show you. So there was a question, is the metal in the meteorite the same as the stuff in the earth? And yes, so I mentioned so that it's an iron type meteorite. So there's often nickel in meteorites as well. And then we can see that one thing that's interesting is if you actually cut a meteorite in half, you can see a pattern on the inside, which is called a Widmanstätten pattern. And it's the way that the metals have crystallized in space as the meteorite formed. It has this really interesting orientation that is unlike anything you would ever see on Earth. So the way that the metal alloys look in meteorites is very unique to it forming in space. It could only happen in space and couldn't happen on Earth. So the alloys are formed a little bit differently, but it is still based on metals that we find here on Earth. Everything that we can find in space, we can find on Earth because we actually came from star stuff. So all of the elements that we have came from either the Big Bang, from stars, from the death of massive stars, from merging neutron stars. So everything that we're made up of and all the elements that we see in our universe are created by cosmic phenomena. So I think that's actually really incredible. I think that we're getting ready to see that view of the double-double shortly. I could take one more question about, let's see, what is a fireball made of? So the fireball is similar to other meteors. It's dusty debris, mostly very, very small and dusty rocks. Sometimes meteoroids can be a little bit bigger, but they are usually chunks that come from the asteroid belt, broken off pieces of an asteroid. Our whole solar system is filled with a lot of dust and bits of rock. So they're composed of those different metals that I mentioned, and then again, a lot of carbon. In some cases, there's some frozen water or volatiles that are in the asteroid belt. Typically, we don't see that in the meteoroids. Anything that's burning up in our atmosphere is mostly metal or those types of rocks or crystals like olivine. And then there is how do scientists predict shooting stars? So shooting stars, as we saw with the different progenitors for comets, if we know the paths of the comets, that we can track that. We know where they went. We know when Earth will actually pass through the debris trail from their tails. So we know every year we're going to pass through the tail of that comet. So most comets that have passed by the Earth, if the Earth's orbit crosses that tail, then we're going to actually get a chance to see an associated meteor shower. So let's take a look at that double-double. We've got it up, coming up now. I think that Chris is going to do a simulation of what it looks like. So we're going to see in the stellarium view the double-double. All right.
So if you put your finger up and put Vega on one side of your finger, the star on the sort of other side, the sort of lower left side of your finger, will be, it looked like one star, but if you look at that star with binoculars, it'll become two. And then if you magnify it greatly with your backyard telescope, you get this view that I'm showing here in stellarium. This orange circle would be the view through your eyepiece at higher power. And you can see that the two stars, each of them is two. So there's two here and there's two here. They're sort of at 90 degrees from each other. And we think that one of these is orbiting the other and one of these is orbiting the other. Sort of a cosmic square dance. So that's the double-double. Its real name is Epsilon Lyrae.
I think only Canadians call it the Tim Hortons star. Is that right?
Well, we like that Tim Hortons moniker because, of course, as we'll get to, I hope, Lyra has both the coffee and the donut. Here we go.
So we can see that is the view. So we're seeing like the two, is it the wide binary, and they're each in the tight binary as well?
Yeah, so each of those bright blobs, if we zoomed in a little more, we might be able to see that each of those is a pair of stars. You can sort of see that the blobs are stretched upper left, lower right for one of the blobs, and the other 90 degrees to that for the other blob. That's the sort of limiting optics of the telescope, sort of smashing the two blobs of light together. Here we go. We're zooming in a little bit more.
That is so cool.
Yeah.
We had a question. Some Red in the Valley said, yesterday morning there was something that my husband saw in the sky around 6 a.m. visually in the east. He said it was big and could be seen as plain as day. Any idea
Venus.
what he saw? I thought that might be based on your presentation earlier. I was like, oh my goodness, I wonder if maybe that was Venus.
Venus, and it'll be there tomorrow too.
Yeah. So around 6 o'clock? Yeah.
Sure. Every morning.
And what's the how long is the cycle for Venus for when it will switch to the evening?
Venus just reached its widest angle away from the sun a couple of days ago, and now it's starting to swing back sunward again. So it'll take it a number of weeks before it disappears again. Yeah, I mean, I could find out in stellarium, but it'll be up for a number of weeks yet to come, and then we'll go through a period where we're waiting for it to return to the evening sky again.
Oh, that's awesome. This is so great to be seeing this double. I think these are such fun things to look at through the telescope, to be able to look at these multiple star systems, because it feels so dynamic, right? Like you think of the stars in the sky and they seem so constant. I mean, they move across the sky from night to night, but we think of them as sort of being these constant things. But when you look at a multiple star system, you realize, oh, they're all in these incredible dance with one another. I think that that's why they're one of my favorite things to look at through a telescope. I think.
And you know what's cool is that double stars, it doesn't matter what the moon is doing. Even if it's a big bright moon, a bright moon will kill all of our nebulas and galaxies that we like to look at, but it'll still leave the stars behind. We can always look at the stars even if the moon is full. That's
true. Let's see. I think we have another question here. Oh, are all stars suns? That is a question from Okan Korsal. So are all stars suns? In a way, yes. In some respects. The sun is a star. So all suns are stars. And I guess it would depend on if you define a sun as a star that has planets around it.
Exactly, yeah.
And our star is named the Sun. That's its our Sol. Yeah. That's its name. And so, yeah, there are many stars now that have planets around them. I was looking at the trivia just before this event, and it occurred to me, we had asked the question, Rochelle, what is the largest planet? But we did not specify whether we were talking about just in our own solar system. Because there are now, oh my goodness, do either of you know how many planets there are in our solar system? Not in our solar system, pardon me. And that in that we've discovered so far in space.
Well, I don't know what number we're at. We think there's at least, is it a million? A million Earth-sized or Earth-sized planets just in our galaxy alone, based on the statistics of analyzing the number of stars we've so far viewed. But
absolutely incredible.
You know, a few decades ago, we theorized that stars had planets, and now we can pretty confidently say that we think pretty much all of them do.
And
a lot of the viewers, the younger viewers, will be able to devote their lives in science studying other planets and other star systems.
That is just amazing to me. I think that it's one of my favorite things, learning about all the cool exoplanets or extrasolar planets that are out there, those distant worlds. The nearest one to us is around the nearest star to us, Proxima Centauri, only 4 light years away. I think. Oh, sorry. I was just gonna say that we are coming up on 10:10. This time has sped by, and I would love to start talking about some deep space objects. Chris, I know that there's a few targets we're going to be looking at, and if you'd be able to just help our audience sort of figure out, orient where we are going to be looking in the sky using stellarium.
Yeah, so this, I've got a view of the evening sky as it would look right now. And you can see that if you had a clear skies and you head outside and look east, three bright stars would catch your eye. And those are the summer triangle. Let's see if I can bring up a shape. There's the triangle. So Vega, very bright Vega, then Deneb, and then Altair. And so that'll sort of start getting you oriented. And we're going to look at a few objects compared to that. So above Vega, you can see this keystone shape, and that's the constellation of Hercules. And if you point your binoculars or backyard telescope about a third of the way from the top of the keystone, there's an object there called Messier 13, which is a globular cluster, and I believe that's what we're going to see next.
Oh, wow. There's
There's Francois' view of it.
That's one of
several
my favorite
hundred
things.
thousand stars, all clumped together by their mutual gravitational attraction into a spherical ball. And the ball itself is about 22,000 light years away from us. So the light's been traveling for all these years to arrive at us tonight. And the ball itself is, I think, sort of a half the moon's diameter in the sky. If you could see all these sort of outlying stars, it would be quite a big clump. But in physical space, it would be 100 or 200 light years in diameter, all crammed into all those stars, crammed into one ball of stars. Wouldn't it be cool to live on a planet orbiting a star inside that system? You'd have no nighttime. It would be so many stars in the sky that the sky would be lit all day long.
I think globular clusters are some of my favorite objects that exist in the universe. One thing that I find so fascinating about them is they're almost as old as the universe, and some of the oldest objects in our universe, in fact. And they are found in the outer halo of our Milky Way galaxy. Most spiral galaxies have populations of globular clusters similar to this one, some larger, some smaller. Most, if not all, stars are formed in cluster environments. So there are open clusters of stars. It's possible our very own sun was formed in a cluster, but one that's quite a little bit different than this one. These globular clusters, as like Chris, you were saying, they're very centrally compact. You described that the sort of central almost ball is very, very tight with stars. I mean, do you know sort of what the degree on the sky, the size of M13 would be?
Yeah, it's about, let me just get the number here. I was just recollecting before. So it would cover about 2/3 of the moon's diameter.
Oh, wow.
But the bright core in the middle would be a fraction of that, a smaller portion of that. But if you're in the country or the cottage and you've got a moonless night, like as we have this week, point your binoculars at that part of the keystone shape that I mentioned, and you might look for that little dim fuzzy patch, and you'll be looking at that very distant object.
And Rochelle, that's a little bit less than that pinky finger you're talking about. Is that right?
Yeah, that's right. I'm just wondering, how many do they estimate are in our galaxy right now?
Ooh, I'm trying to remember.
Well, we can't see the ones that are hidden by the disk of our Milky Way because, of course, it obscures the light from the globular clusters. But based on the rest of the distribution, there are dozens to 100, I think, somewhere in that range. So quite a few. And as Rachel mentioned, we've seen globular clusters around the Andromeda galaxy and other galaxies. So it's amazing that we can find those same structures in other places.
Yeah, we have a question from Lee Gang. Wait, is it the Hercules cluster that was shown? Yes, this is indeed the great Hercules cluster. Also goes by the Messier number M13, named after Charles Messier's catalog of objects. So some of these targets have almost like a catalog number, and then they have like a nickname. So this is the Hercules cluster.
And just to circle back to the comets, apparently Messier was trying to make his name looking for the next comet. And when he started looking through his telescope, he found so many objects that not exactly sure, which is why he started to number them so he wouldn't get them confused with the comet. At the time he was working, and
he was looking for Halley's comet. So
exactly.
Halley predicted. Edmund Halley predicted using mathematics the orbit of the comet, when it should return. He died before it came back, but he left this legacy of this information. And then all the avid comet hunters, of course, in those days, you got your name on the comet if you saw it first. And so Messier was one of many people around the world who expected a comet Halley to arrive at a certain time, and hoped he'd be the first to see it. But unfortunately, he got scooped by about 10 days by a German astronomer.
Oh, 10 days.
But it did spark his interest, and he ended up discovering many, many comets of his own later on, and creating his famous list.
Yeah. At the Science Center, we are encouraging anybody who's interested in looking up and keeping their logbooks, because who knows, you might find some kind of interesting object, and then later on it has to get verified. You could be contributing to this broad field of science just from your backyard.
That's such an awesome tip. That's a great reminder. And Rochelle, I would love to do another round of space trivia with you before we transition to another deep space object. You ready?
Okay, I'm ready.
All right. What's our first question?
I believe our first question, I gotta go back to the notes. Sorry. If you were listening carefully to let's see. If you were listening carefully, oh, sorry, can you hear me?
Yeah, I can hear you. Yeah.
To Rachel's presentation, what are dirty snowballs called?
Here we go. What objects do we call dirty snowballs? So feel free to take your votes. I mentioned it earlier. Put those into the chat. And so we'll give you a few seconds for that. We've been talking a lot of different things so far tonight. So for those of you just joining us, welcome. Please feel free to participate as well. If you know what objects in space we sometimes refer to as dirty snowballs, that would be great to put your guess or your answer into the chat. All right, and tally it up. Drum roll.
Yeah. Do we have? And the answer is Rachel.
Yeah, comets. Yes. This is a stunning view of Comet Hale-Bopp. I think in the 90s, Chris, I think maybe, or Rochelle, you might remember is it 94 as the year Comet Hale-Bopp?
Oh, gosh, I can't remember off the top of my head.
I just know from this image you can really see those two tails, the blue gas tail and the white. There was a question from earlier. I was asking what the blue was that was in the image. It might have been from the image that I was sharing of the comet Neowise as it was passing near to the sun. So that image actually, I didn't mention, but it was actually taken by the Parker Solar Probe. It's a very, very close probe that's orbiting our sun, monitoring our sun. And so as the comet Neowise was passing by, a few days after it made its trip around the sun, it was photographed by Parker Solar Probes. Very cool. So next question.
Next question. Where are most asteroids found in our solar system?
Ooh.
Yeah.
It's a good
we
good
talked
one.
About that too.
So I mentioned those meteoroids that fall through our atmosphere to become meteors, and then if they survive to the surface, become meteorites. They typically come from asteroids, broken off of asteroids in our solar system.
Yeah,
so,
very famous belt. Have we got answers in the Yahoo chat?
Yeah,
the YouTube chat?
Yeah, we're seeing some responses coming in. Just give a few more seconds. Asteroids can be found sort of all throughout our solar system, but we're asking where are they most commonly found? Okay, we've seen some say the Kuiper Belt, Some say in the asteroid belt. All right.
Where? Yeah. Okay. I think we can give the answer. And of
And
course, yep.
yeah,
Oh, the asteroid belt between Mars and Jupiter.
yeah, that's right. So give yourself an extra point if you knew where the asteroid belt was. Not just that the answer was the asteroid belt, but that it was also between Mars and Jupiter. Ah, we have somebody who answered that. Thank you. That's great. All right, one last question, and then we'll fly off to another object.
One last question.
I've heard some rumblings in the chat about this one.
Okay. Oh yes. When was Pluto discovered? And when was it reclassified as a dwarf planet?
That's a great question.
Yes.
We had a question earlier from A. Weir. Does Pluto have any moons, and can we see Pluto from Earth? So Pluto does have moons. I think it has Charon is its largest moon, but I think it has 4 now. Is that right?
Yes.
I think it's
thought it was 5.
5.
Yeah.
Is it Nix and Hydra, or two of them? What are the other? Kerberos, and I can't remember the last one.
Maybe somebody out there can put that in the chat.
Yeah,
if
someone knows the
last moon
of Pluto. And
a lot of them confirmed by the New Horizons, right?
Yeah.
Yeah.
And can we see Pluto from Earth?
I have them if you want them.
Go for it, Chris.
Charon, Hydra, and by the way, the moons of planets are all named using a theme. So the moons of Pluto, Pluto being the god of the underworld, are all named after different cultures around the world, their underworld deities. So we have Charon, and Charon was the boatman taking across the river Styx in mythology. We have Hydra, Kerberos, Nix, and Styx. And I remember NASA had a contest to name the last 2 moons it discovered, and I voted for Kirk and Spock, but they didn't want to go for that because it didn't honor the theme that they were going for. But I thought that would have been fun.
I think a lot of the craters and features on Charon are actually named after popular science fiction characters. I don't know if those have been approved by the International Astronomical Union yet, but I had seen some things that were like Dalek and some Kirk and some Star Wars stuff. Lots of variety there.
What I thought was cool was on Titan, all of the mountains are named after the mountains from Lord of the Rings. And all the lakes on Titan are named after famous lakes. There's another Lake Ontario on Titan.
Oh, that's so cool. Oh, wow. I bet it's not filled with water, though.
Nope.
Well, we do have some answers. We see 1930, 1990 for the discovery. And Pluto was first discovered in
1930.
1930.
Good for
That's
you.
Right.
Got some people who said 1930, yes, and someone who said 2006, yes, for the reclassification as well.
That's right.
Awesome.
I've had a lot of people petition me to ask people to reclassify Pluto as a planet, because as a kid you grow up, you learn about the 9 planets, and there's a lot of nostalgia there. So you'll have to petition the International Astronomical Union, because it was in 2006 that the majority of the astronomers decided that there were new criteria for classifying planets, and Pluto didn't quite meet the criteria, but it's still an interesting object. It still has a lot of similar features to other planets, but yeah,
it's now the largest in its own category.
And it's still there.
Yeah.
Students ask me all the time, is it still there? What happened to it? It's still there. It's just a different style of planet. Just like a blueberry is a fruit, and so is an orange. Pluto is a small fruit versus a big fruit. It's just a minor planet, a dwarf planet versus a large planet. But
and
it's still there.
Its heart.
Yeah,
I love its heart too. Yeah,
because science is
that
always
heart is a
growing,
glacier.
Right? Yeah,
that heart is a glacier. It's all nitrogen ices and different types.
Yeah.
With every new technology, we learn new things, and we see things that we never saw before, right? And I think Rachel, aren't we about to see some really cool stuff right now through the telescopes?
Yes, we are. We are going to take a look at the Ring Nebula, I believe, through the telescopes. I think Francois has pulled that up for us. Oh,
That's amazing.
Wow.
oh my goodness, Francois, that is beautiful. Nebulae are some of the most striking objects. Some of you watching may have seen images of these objects taken by the Hubble Space Telescope. These can certainly be seen from ground-based telescopes. Francois has taken this image using his telescope setup and camera from his home in Trenton. I think that this is just beautiful. And from what I understand, there's actually no post-processing on this image. That this is mostly just a raw image that we're seeing. So very similar to what you would see if you were looking through the telescope yourself. I know, having looked at the Ring Nebula, also called M57, in the constellation of Lyra, I believe it is, also similar to that double star we were seeing earlier. It does tend to have that green tinge to it, to the
I
naked
see it
eye.
in black and white when I look at it, but what I love about this object is that it's super easy to find by amateurs. It's there's a real trick to finding it that's really, really easy. And if you want, we could show you in stellarium here.
Yeah, let's just leave it on here for a few more minutes and see if there's any questions about the Ring Nebula. Just checking the chat right now. As I mentioned, lots of different types of nebulae are in our galaxy. These are places where stars are forming. In the case that we're seeing here for this Ring Nebula, this is a planetary nebula. And what that means is that this is a star that's reached the end of its life. It's puffed off as outer layers of gas. So this is sort of an eventual fate of a dying star. But all of that gets recycled back into our interstellar medium and builds up again to form a new generation of stars. I would love to see in stellarium, Chris, as you were going to show, where we can spot this if we wanted to try to find this ourselves in the sky.
So find our friend Vega. That's that very, very bright star high in the eastern sky. And then about a finger's width below that is the top of a parallelogram of stars, this sort of box. And if you point your telescope using a low magnification eyepiece exactly halfway between the line joining the bottom of the box, that's where the Ring Nebula is. And in a sort of a smaller telescope, you should see a tiny little ring. It won't be color. It'll be black and white, but you'll see that ghostly ring shape. It's actually a ball of gas, but it looks like a ring to us.
And something that I found helpful if I'm looking through binoculars or a telescope at a deep space object like this is using the averted vision. This where you take the the peripheral of your eyes are a little bit more sensitive. So it's kind of almost, if you don't look directly at it, you sort of focus maybe on a star that's next to it, and then you can see it a little bit more clearly. Is that right?
Yeah. Yeah. Look for the little bright speck in the middle of the ring. That's the former core of the star that blew off its shell. That's a white dwarf star. It's a cooling ember, millions of degrees hot, and its radiation is causing the gas to glow in that sphere.
And that might be the fate of our own sun in the future.
Yeah.
4.5 or so billion years from now.
Just amazing. I'm conscious of the time. I would love, if we have it, to see one last view of Mars. For anyone who's just joining us who didn't get to see it earlier, Mars is going to be rising after we end off here tonight. But want to give you a bit of a tease of a recording of Mars from last night, seen through Claudio's telescope. For those of you who Mars was your favorite, here's a last view of the red planet. Something to look forward to in October as it becomes to its closest and brightest to us. So this has been just a beautiful, beautiful view. Thank you for sharing that with us, Claudio.
So Rachel, we should remind people that depending on the way their telescope works, it could flip Mars upside down. So the bright polar cap might be near the top of the planet in their view through the telescope, depending on the type of telescope you have.
That's a great tip. That's a great point. So it might not look exactly like that orientation, but you certainly should still be able to spot it with that distinctive red planet color. All right, we have reached the end of our event. I want to thank all of you for joining us this evening for our first virtual star party, participating in some fun trivia, answering all of our questions that we threw out to you, and hope you enjoyed all those amazing telescope views. We saw Jupiter, we saw Saturn, we saw some double stars, we saw Mars, we saw Ring Nebula, and we saw the globular cluster. I think that was it. Was there anything else that Chris, you or Rochelle would want to add?
No, just go look up.
Look up, yeah.
That's how people learned thousands of years ago, and that's how we're still learning now. Look up.
Print your
Absolutely.
star finder out, start learning where the bright stars are, and then from there you can navigate from them to the dimmer stars and the other objects that we've talked about.
Perfect. Those are great tips. I encourage all of you, if you enjoyed this event, please like and subscribe to our channels for the Ontario Science Centre and the RASC Toronto Centre. We each have a lot of fun talks and activities to share with you as we connect with you virtually, even though we can't be all together in person. We also have on the Ontario Science Centre's website a mailing list you can join to be informed and kept up to date of events like this one that are coming your way in the future. So I want to thank the whole team that's been here with us tonight, our audience, Chris and Rochelle. Thanks so much for the chat. It's been a lot of fun. I want to thank our telescope operators, Blake, Claudio, and Francois, and of course our team behind the scenes, Ward, Angel, Jana, and Andrew. Thank you, everyone, and have a great night. Take care and stay safe.
Thanks.
Bye.
Bye.
Keep looking up.
Yeah.